In this video, we're going to look more specifically at the halogenation reactions, fluorination, chlorination, bromination, and iodination. And we'll look at the mechanism specifically for bromination, which then pretty directly then connects to the other three as well. So each of these reactions has slightly different reagents. We can't just use the halogen like we do with addition reactions. For fluorination, the halogen F2 is actually too reactive. For the other three reactions, the halogen is not reactive enough. So we need some kind of specialized reagents to do the EAS reaction with benzene. So for fluorine, you're going to use, this is kind of a complicated, not even a word, acronym here. So this is how it's commonly represented. It's a pretty complex structure. Draw it out here real quick. Right, so that's what the structure looks like, which is even more complicated. So this acronym is very commonly used. So you can use that as your reagent over your arrows in your reactions. For chlorination, you're going to use chlorine along with iron chloride. Here that iron chloride is a catalyst, so it's not used up in the reaction. Bromine, you are going to use bromine, and you're going to then use iron bromide. Unlike the iron chloride, the iron bromide is not a catalyst and it is consumed in the reaction. For the iodinization, we'll use iodine plus copper chloride. Again, that is going to actually be used up in the reaction. So for the bromine, what is actually formed from these two? You get this complex, and notice now the bromine has, kind of seems unusual, positive charge, so it actually becomes the electrophile. For the iodinization, what you end up getting are two iodine cations and two copper cations. And it's really the copper, not copper chloride. The chlorides are just kind of counter ions. Right, so they kind of come along for the ride. So two copper ions are going to react with the I2 to give you iodine ions, copper ions, and you still have the chloride ions floating around as your counter ions as well. Actually, there's 4 of them. Right. So these are the different reagents that you want to be able to recognize. So the fluorination reagent, chlorination reagents, bromination, and iodination. For the mechanisms, you're going to want to know that for the bromination, that bromine and iron chloride transfer into your complex. For the iodinization, you need to know that you're forming the iodine cation. Right. So let's look at the mechanism specifically for bromination. The first step, if you're asked to do the bromination mechanism, is you do want to show that you're starting with bromine plus the iron bromide, and that is converting into that complex. Now that we have that complex, the benzene will be our nucleophile, and it will attack that electrophile bromine. This then forms our sigma complex, which is always the first thing that forms. So we now have bromine attached to our benzene and our carbocation. Full mechanism should show the resonant structures. Oops, sorry about that. So there's one. Here's the second resonant structure. So there's our three different sigma complex structures. Now that FeBr4 is what's going to come in, and that has a negative charge. That was my mistake, sorry. Still have a negative charge. That is what's going to come in and remove the hydrogen to reform our benzene. And our bromine is now attached. So there would be your mechanism for bromination. Again, the other halogenation mechanisms are very similar and can be found in textbook and other resources.